Alright, let's do it. What are we doing today? We are doing 3.4 and 3.5. 3.4 is on measures of position and outliers. Talked about outliers before. 3.5 is on the 5-number summary. And the box plot. Now, when we get to the box plot, StatCrunch will do it for you, but we're going to walk through it once by hand so that you know what buckets they're looking at. If you've done it once by hand, or have it in your notes, you'll at least understand what the box plot is trying to show you. Otherwise, there's a whole lot of shit there, and you're like, huh? Like, it's fucking meaningless. Quick recap, empirical rule. Ah, shit, that's not fucking centered very well. Oh, well, fuck it. Pretend that looks like a nice centered hump. In the center, we have the mean. Mu or X bar. And we go left or right 3 clicks. Left once and right once is about when the graph is about halfway down. That's about where it is. This is mu plus 1 sigma, this is mu minus 1 sigma. Then wherever far that is, keep doing that again to put that distance again and add 1 more sigma each time as you go to the left. And subtract 1 more sigma as you go to the right. So the fun fact about this symmetrical distribution. 50% is to the left. 50% is to the right. And so it does stuff equally in each direction. When we go over 1 deviation. There's 34% in each of these. Which gives us a total reach, if we go left or right one, 68%. We go another one. Fuck. Hit it with my sleeve and it powered off.
Pass it over.
No. You're always welcome to leave at any time, but I'm gonna keep
Yeah.
lecturing and expect you to know
That
this
was
shit, so.
That was my. Okay.
Going left or right again is 13.5%. To be honest. The way I remember it. I don't remember the 13.5%. I remember that these two. Between the left and right one here is 95%. And I go, this is what I do. I say 95 minus 68 gives me 27. And if I divide 27 by 2, I get 13.5. That's how I remember it. It can be a pain to memorize little details like this, but like the percentages matter. If these two are 95%, that means between this region over here and this region over here, we can only have a max of 100%. This means these two regions split up 5%, which means there's gonna be 2.5% after that and 2.5% after that. The way to remember what goes here for the third deviation is just put a 3 in there, 2.35%. So going out 3 deviations captures 99.7% of the data. Which leaves just 0.3% left. If we split 0.3% in half, we get 0.15%. That's everything past that has a very low percentage, 0.15%. Is with me on that? A common one that they like to do is the IQ test. IQ test has a mean of 100 and a standard deviation of 15. And so we can fill this in by putting 100 in the center. And just keep adding 15 as you go to the right. And keep subtracting 15 as you go to the left. What's my feelings?
Yeah, sounds good.
You wanna feel bad too? You want me to give you a poster?
No, it's alright.
So like if they said if it was something different. Let's say they gave us mu was 70 and sigma was, I don't know. 6. Put these little lines down here and we can calculate them. Put the 70 in the middle. And you keep adding 6 as you go to the right, so this is 76. 76 plus 6 will give me 82. 82 plus 6 gives me 88. And I will subtract 6 going to the left. 70 minus 6 is 64. Then we have 58. And then we have 52. Someone, and I'm only gonna sketch the basics of it. People are still writing, so let me leave that up there, guys. Let me pause so much ago. Blackberry drink isn't too bad. Starbucks. I have a new Blackberry refresher. I generally don't like eating blackberries because they're like. They got lots of little seeds and shit in them, but. Hard. So let's say we have a random person here, like, let's say we're talking about height. Yeah, let's say this graph is on height. And I don't know where someone's position is. Let's say it's like right here. Let's say this person is at score X, not X bar. This is like, remember when we said like the elements were the height data element was Xi? That's why we're gonna use X. I can write this X as mu. Plus. Some question mark number of deviations away from here. Now, question mark could be positive. If it's to the right. Over here, question mark would be negative because it's to the left. But they don't like using question mark, they like using Z. So this is like the individual's data. That's the mean. That's the standard deviation. And so Z is the number of deviations. Away from the mean. How tall are you?
5'4".
Care to be the example in this next part here?
The next is the 2 weeks.
No, do I look stupid? Don't answer that, I'm sure I do. The glasses usually make people look smarter, but it doesn't always the case. Just look at that, no, I mean.
My 16.
Right?
Oh my.
I did that to my wife before we married Emily. She got so mad, like it was actually threatening to hit her. Like, I don't know, like, just like play acting. Now she does it to me all the time. She knows I was just fucking. She was mad and shit for someone did it. Alright, Bowser, everyone looks like you're done right now. Yeah, I'm saying that. Back. So I am like a little bit taller than her, not much. I'm taller than her, but like. Guys in general are taller than women, right? Because statistically speaking, this is the case. This isn't true for all, like there's plenty of women that are taller than me. But I'm on the short side, I'm 5'5.5". I'm really proud of that, 5'5.5", that extra half inch, because it matters when you're short. My friends make fun of me because they're all fucking in like the 5'9" plus range. So everybody looks down at me when we're standing up. So like, we're both like. On the short side a little, I don't know. Women tend to be taller than 5'4", they're around 5'5" or so. So she's a little short, I'm a little short, but like. Relative to our genders, I assume you identify as a woman. Relative to our genders. Which one of us is taller percentage wise?
You.
I like your answer, Chris is over here immediately pointing about, let's find out. So this is what we get. It's kind of hard, like, how do I compare my height to Val's height. Well, I can tell you, and this changes every year, so I'm gonna use the numbers I haven't written down. For males. That should be an M. The or the mean is 70 inches. And the standard deviation is 4 inches. The double apostrophe is inches. For females. The standard deviation, at least at one point, was 65 inches. And the standard deviation was 3.5 inches. Well, we're at a little bit of a dilemma here. We're already starting off, because I said FA is 5 foot, 5.5 inches. And Val clocked in, she said she's 5'4". So already we've got feet and inches and like standard deviation in the mean is in inches. So we're gonna need to convert Hefe and Val to inches. So going from feet and inches to just inches. Well. There's 12 inches in a foot. 12 inches per foot. So you take it and you multiply the person's foot score times 12. And then you add in whatever their inches part was. What that means is like with the numbers, FA is 5 times 12 plus 5.5. And Val is 5 times 12 plus 4. 5 times 12 is 60. So Hefe clocks in at 65.5 inches. And Val clocks in at 64 inches. Now we can see, now that we're down to inches, we can see we're both less than the mean, right? So we're both over here. Val and Hefe are over here. Are below the mean. Which one's further below?
Val.
We're gonna calculate it mathematically. I've changed the wording around, now Chris pointed the right way. I like, Arturo's got my back, Chris said clearly doesn't. She wants to add, yeah. So really, the real question, Mike, like if I look up here. The easiest way to check is like, well, how many Z's are we to the left? Looking at the picture. How many Z's are we to the left? So I'm gonna go up there, I'm gonna write down that formula we had, x equals mu plus z times sigma. And we're gonna solve for z. Now, if you don't like solving for z, you don't like doing algebra, you can just memorize the result. But what we do is we subtract mu from both sides. And we get x minus mu equals z times sigma. So I subtracted mu. And now from here, I'm gonna divide by sigma. If I divide the left side by sigma, I get x minus mu over sigma. And on the right, if I divide that by sigma, and the sigmas cancel out, I just get Z. So the Z score, which is what this is called. Is a formula, it's X minus mu over sigma. Which is the individual score. Minus the mean. Over standard deviation. So we're gonna calculate Z Hefe. And Z bow. Hefe's height was 65.5. The male average was 70. And the standard deviation was 4. You definitely, if you're doing it in a calculator and do it all at once, put the top of parentheses because it needs to be done first. This is negative 4.5 over 4. And I'm getting negative 1.125. With a negative in there. Which means if I come up here to my graph. I didn't put my blue line in the right spot. Hefe is less than, it's more than 1, so like Hefe is actually past the 1 mark. Hefe is right here. Now, if Val is to the left, I'm taller than her relative to my gender. And if Val is to the right on the graph, she's taller relative to her gender. Let's calculate Val's score. Val she was 64 inches. The average height for females was 65 inches. This is not looking well for me. The bottom is 3.5 inches. This is negative 1 over 3.5, which has got to be like negative 0.3 or some shit like that. Negative 0.29. So maybe putting it on a graph where like I don't have a lot of clutter there. FA was right here. And negative 0.3 basically is closer to 0 than it is to negative 1. Val is like here. Put this into some perspective. Remember we said this region here was like 13.5. And to the left of 2 was 5%. Which means Hefe is taller than less than, if I add those two up, 13.5 plus 5, than 18.5% of men. Fuck. I'm like really on the fucking low end here. That's on the fucking short shit end. Even my friends in life do have a fucking something to pick on me for, they're like, oh, wait, we're at like someone's house. If the things are down low on a cupboard, they're like, let Dave get them. And then like if it's in a cupboard like up high, they're like, let's watch Dave get them, that's gonna be funny. Cause he's too short to reach them. Val. I don't know, this is a little tough, this was 34%. Remember, the whole like 1/2 was 50%. And she's closer to Mew, I'm guessing Val is maybe taller than about 40% if I'm estimating. But mine was less than 18.5. Mine is probably like 15% or some shit like that. Like. That means most men by a far margin are taller than me. So yes, Val is taller relative to women than I am to men. It basically means there's more women that are shorter than her than there are men shorter than me. For someone, an adult male, I should say. The average adult male. That's how this is called a measure of position. These are. Measures of position. In our categories. So what's good about this? By converting to a z-score. We can compare. The position. Or. Ranking, if we were ranking them by height. Things from different groups. Also oranges, as they like to say. I'll call you Krista. What? You guys should pick you. I like to win, I just lost.
I didn't. So you something so.
I beat you.
Yeah.
But I bet not by much. God, that's really close. You like negative 1.3 or something like that? So that's like different kinds of ranking. This works really, really well. So this z-score thing. Is fantastic. For data that lies on a bell curve. Not so good for skewed data. For skewed data, we use something different. Like skewed left or skewed right. That's like, it's not like symmetrical, it's not 50% to the left or to the right on a skewed graph. We use something different, we use the median. And IQR. And I haven't said what IQR is, I gotta show you. This stands for interquartile range. IQR. So bell-shaped, we use mu and sigma to get z. For skewed, we're gonna use the median and the IQR. So what the hell is this IQR? This has the word quartile in it. What word does that sound like to something you know in real life? Sounds like a quarter, right? A quarter is 25 cents, right? Or we treat it as a fraction of a dollar, it's 1/4 of a dollar. Or 25% of a dollar. And I think 25% is the easier way to take a look at this. In fact, I only wrote down 1/4 because Krista said it out loud. It's her fault, that's on the table. I blame her. So how do we do it? I don't know, like, depending on, it doesn't matter if the graph is skewed left or skewed right. The idea is, and we'll show it like when we do the box plot really well, it's gonna show it really well. If we say the minimum is down here and the maximum is up here. Like the minimum score or the minimum data value. Then the middle on like the bell curve. So what I'm gonna show is the bell curve version. Because it's slightly different for the skewed ones. 50% is there, I told you there was 50% to the left or 50% to the right. The way we do something called percentiles. Is what percent is to the left? That's what a percentile is. In fact, if you are in high school or took the SAT while in high school, the SATs report stuff as a percentile. They tell you the percent of people that took the exact same test, what percent higher, or what percent of them you scored better than. If you decide to go to graduate school, there's something called the graduate, it's called the GRE, it's graduate requirement exam or some shit like that. They give you a similar one. I had to take one for mathematics. I got a depressingly low score, I was like at 60% or some shit like that, like. I was above half, but not by much, but. I was enough to get into almost every single grad school and. Where I wanted to go, because like the math one had applied math and pure math on it. The graduate exam, if you decide to go to grad school, don't guess, if you guess wrong, they deduct points. It's not worth 0, it's worth deduct, so you don't guess on the graduate test. You only, like, if you don't answer, it's just 0. If you answer and get it right, you get points, if you answer and get it wrong, you lose points. So I avoided answering shit I didn't know. So for like what we had earlier, Hep A was like less than the 18th percentile. And Val was about the 40 percentile. To compare that to what we were showing earlier. I know, it's probably a new word for most of you. Hopefully you know percent, hopefully you know quarter, and you can relate what's going on. So if the full thing's the whole thing, half of it's this, a quarter of it is like literally halfway between the min and the 50% mark. This is the 25% mark. This is called the first quartile. So quartile is like percentile and it starts representing increments of 25%. The middle one is technically, the 50% mark is the second quartile. But we just call it median. But it is the second quartile, it's 2 times 25. The third quartile is at the 75% mark. This is third quartile. We tend to call this one Q1. And this one Q3. Just because you get tired of saying and writing quartile. Q is for quartile. Fun yet? Don't shake your head, Arturo, I know you're not having fun. What a liar. Alright. So where does this median and interquartile shit come in? Median is the 50% mark. The interquartile is a calculated, it's the value at the 50% mark. And IQR is you take the scores for Q3. And you subtract Q1 and you get the IQRs. It's handy because we literally need all three of those things, the median, Q3 and Q1. For the 5-number summary, show up in the 5-number summary in the box plot. We're gonna do a little bit. In StatCrunch. We can go stats. Summary stats. Columns. And you need to have the column data. You need all the data values. If you're finding these by hand, then we're not going to. Finding the median, we already did. You sort the data high to low. Or from low to high. And find the middle value. And it's the middle value between the min and the max. The min score and max score. The min score is like the 0 percentile, and the max score is like 100 percentile. To find Q1. Do the same. But it's the middle. Value. Between. Min and median. You're only going up to the 50% mark. Q3 is middle. Median and max. And so the order they go in is min. Q1. Median. Q3. Max. They represent 0%, 25%. 50%. 75% and 100%. We're gonna use that in our next section after we take a break. Before we do. No, we'll talk about the outliers after the break. Let's take a 10-minute break. Working so that. I can stay fun. What an ass. Alright, so outliers. How do we determine outliers? We talked about outliers. Outliers can affect resistance. Or whether or not a stat is resistant to outliers or not. We don't like outliers. If we had Bill Gates or Elon Musk in here, the average fucking income is way more than everybody makes but them. Like I'm nowhere, I'm probably make the most in the room, and still, the average is, I'm nowhere near the average income with one of them in here. Especially not Elon, now that he's got access to the fucking treasury. He cannot use the treasury for his own money, but still, that was a joke. Still, his income is way higher. So what we do for bell curves. That's where we're looking at mu and sigma to calculate z. We're gonna go with outliers have. Z less than -2 or z greater than 2. So that means. To the far right, outside of 2 deviations, and to the left, 2 deviations. You might see this is listed as. Absolute value of z is greater than 2. But what that means, if you write it and split it up and don't use the absolute value, is it means that. So just z's that are bigger than 2. Plus or minus 2. We don't like outliers, they make our shit go bad. Skew data is different. Sometimes data sets have outliers, sometimes they don't. So we gotta make it so like the way they decide it is. It's based on the following. They have a lower fence. And they have an upper fence. The lower fence is calculated by taking Q1. And you subtract 1.5 times IQR. The upper fence is Q3 plus that. I don't think StatCrunch tells you where the fences are, but it will give you all these data values, and we will calculate it by hand. We're gonna do an example in a second. Pictorially, what's going on, so like, it will kind of make sense. You got your house. And you know, you live in the suburbs, you got other houses around you. But this is my house. And I've got. A front yard with fence. And that's my fence. And I've got a backyard. And I've got a back fence. An outlier in the terms of like property, outlier is effectively like outsider. Someone outside your property. So you could have people behind your back fence or in front of your front fence. That's effectively what's going on. We're gonna see this in the box plot. So how this relates is outliers are. Less than the lower fence. Are greater than the upper fence. Carol, Jesus Christ, what's in class? Gwen Val, but she's too far away. Gwen Val,
I'll take this.
so yeah,
I don't care what you.
that's it. You will find the older you get, the less fucks you give.
Oh, God, that's so true.
In fact, I hear the 50-year mark is called the fuck it 50s. You get to 50 and you're like, fuck it in general, period. I don't know, get pretty fucking close. Pretty close to 50 and I already know I'm in the fucking zone for most things.
I was gonna ask you, where do you lay on that?
Pretty much, I don't give a fuck what most people think. You learn to like, some people approve or like what you say or what you think and others don't, and you will find out the longer you live. The less relevant you really like, it doesn't really matter. For a long time while you're younger, you want as many people to like you as possible, so like, you don't want people like disliking you. For whatever reason, but as you get older, you're like. Who the fuck are you? I don't give a fuck about you. You only apply it to people that are close to you, your family and your friends. And even then, there are some things that your line is firm, I'm not budging whether they disagree with me or not. Alright, let's go to StatCrunch real quick. And take a look at a data example, get some values, and then I'm gonna come back over to the graph paper and do some stuff. It's a good thing, Arturo. The fuck it mentality is a fucking fantastic. Isn't it great, Val?
It's fantastic.
It's fantastic. You stop stressing about what other people think. It's stressful. It's really stressful caring what other people think. That's the way I like dying. Stress is bad for your system. It's bad for your health. Alright, I'm gonna come over here, I'm gonna sign in. Hopefully, you should be able to work on assignments late, you'll get full credit. So if you were a little late, something happens, you don't need to email me.
Like on the latest image, whenever you click on them, it refreshes the page, it doesn't let them open up. There are a reason why, or are they locked or something? Cause I thought I was the only one because I was having.
They shouldn't be locked, but I can take a look right now real quick, cause I keep fucking unlocking them.
Yeah, I don't have 1.1, I don't have that whole chapter, I only have 2.1 and.
Motherfucker, they keep turning it off. Apply settings. It's applied.
Another is,
Come down here, say done. I'm gonna verify this, cause you guys are watching me do it. If I come in and look at the assignment of settings. It says late submissions are allowed. Now, if this shit changes tomorrow. And you guys, like, someone tries to log into a late assignment, like it's like, even if you already did the entire assignment before. Someone try this tomorrow after like the night resets. And find out if you'll like access the old assignments, because if not, it means. Either I'm fucking going senile, cause I swear I've done this 2 or 3 fucking times already. Or Pearson just keeps fucking up and undoing what I'm doing. I can see it says late admissions allowed when I look at that particular assignment. And I can go to another assignment. One past what we're doing, look at it there and make sure it works down here. Yep, there's late submissions, that's allowed. So if it like changes and you don't have access to late assignments, let me know. So that I can like call and bitch out Pearson. Cause I swear I've answered this done a couple times.
So we try right now.
Well, it should work right now, I just said it.
Working.
It's not working.
Log out, log back in. You're already logged in. See, Aaliyah's like, y'all don't know what you're doing. Just get your shit together, she said.
Oh, yeah, my shit working.
Yeah, if it wasn't working, try logging out, logging back in, it should work now. Maybe even refreshing would work. Okay, back to what we were gonna do over here. I was gonna go over to StatCrunch. And I'm gonna visit the StatCrunch website. And. Look up data sets. You wanna follow along, you should be able to. Let's look up Jones Hefe, that's gotta have something. We're gonna use a bunch of these later on. Which ones of these are good for this? What is that one? Let's check out this one. There's no numbers here, that's not helpful. Let me try getting to this. Jesus. Turkey Day Travels? Turkey Day Travels has numbers. Oh, I don't like that. We go back to my data and give you a name to look for if you want to follow along. It's a group, it shouldn't have shit in it yet. I'm gonna show you. Pick a random data set then, and you can pick a random one on the StatCrunch. I'll show you a bunch. Alright, so we're gonna do stats, summary stats, columns. I'm gonna. Oh, let's do age and height. So on this list, I can go through and if you want to select them in order, that's probably like the best way to do it. Because when you're doing 3.5, the questions in there are gonna use the following 5 things. They're gonna use the minimum. And then scroll down and click, click Q1. And then scroll for median. And get Q3. And then get max. They also have IQR, but we're gonna calculate that by hand, but I'm gonna show you, should get you the same thing. So we can work, you guys wanna do age or height? Age. Alright, so I'm gonna write down those numbers from age on paper. And then. We'll work with the 5-number summary in a second. Apparently, I had a 14-year-old in this class at one point. I'm pretty sure that 79-year-old was my mom. I am Unless they took it online and they do not picture a 79-year-old taking an online class. Like you've seen like. If you've never seen grandma or grandpa in front of a fucking computer, it's fucking fun to watch. Just don't let them do it on your computer, cause they will fucking virus infect the shit out of your stuff. Alright. Let's switch back over to. My numbers are down. These are called, this is called the 5-number summary. Three point five is on this topic. When that problem's asking for it, there will be homework problems, like in stuff, they ask you for the 5-number summary. They want it in this order. Min, Q1, median, Q3, max. If you type them in, have all the right numbers, but you put them in the wrong order, they're gonna say you got it wrong. Because you put them in the wrong order, they go in order. Let's take a look at that lower fence and upper fence thing I was telling you about. Lower fence. Just as a reminder, this was Q1 minus 1.5 times IQR. I'm gonna give myself some space to do the calculations, and I'm gonna do upper fence down here. Q3 plus 1.5 times IQR. And maybe I should have done this first, IQR is Q3 minus Q1. My phone is sitting on the table and I just did that zzz, 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 like I got a message. And it vibrated the whole table enough that my foot shook. Jesus, a little tiny vibration, Jim, it's pretty crazy. Alright, so it looks like I need this IQR thing in both of these. So I need to calculate IQR first. Q3 was 33. And then I'm gonna do minus Q1, Q1 was 19. 33 minus 19, if we throw it in a calculator, we do get 14, which was the IQR. Now. 1.5 times IQR shows up in both of them. Rather than calculating it twice, let's just calculate it once. 1.5 times IQR is 1.5 times 14. And if you do 1.5 times 14 in a calculator, you're gonna get 21.
You just missed like, you just skip like all the steps right now. That's the jump.
I didn't pull out the calculator, but I can. IQR was 14, I'm doing 1.5 times 14. 21. Calculator work. What's wrong, Arturo?
I don't know, that shit was really quick. That change, you said,
I did it really quick because I'm comfortable doing 1.5 times something if it's an even number.
yeah,
I can quickly, like, I can identify half of it, like the way, how I did it quickly. I know half of 14 is 7, oops, 7. And 1.5 is like 150%. Which is like 100% plus 50%. So adding the two, 14 plus 7 is 21. I did that quickly in my head, you don't need to do it quickly in your head. You can do this in the calculator. Okay?
Alright.
When you use this is more helpful for knowing what's happening, where it's coming from. When you do the graphing that we're about to do, the computer is gonna do this part for you. It's just not gonna tell you what these fences are. If we're gonna use these fences The fences are used. To identify outliers. And StatCrunch will do this for you. So like on the test, you do not need to calculate this shit by hand. You can add. I don't think any of them ask you what the lower and upper points are. But for me to show, like showing you what the box plot is, walking through it by hand does help. Let me pause, make sure everyone's got that, then we'll go do the lower fence and upper fence. You do not need to remember how to do this box plot summary. Having seen it done will help you recognize what the fuck you're looking at when you look at a box plot, okay? So if I were doing this, Q1, I'm pulling from up here is 19. A little bit more visible. Q1 is 19 up there. And I just said 1.5 IQR is 21. From below. 19 minus 21 is -2. The upper fence, we do Q3 plus 1.5 IQR. Q3 from up here is 33. And then we do 1.5 plus IQR or times IQR, we said that was 21 down here. 33 plus 21 is 54. Again, you don't have to take my word for it on the addition, you can throw it in calculator, verify that's 54. What this means is if there are scores lower than -2 or greater than 55, 54, then those are outliers. You can figure this out without looking at a picture. Cause you have the minimum score and the maximum score. The minimum score was 14. Is 14 less than -2? No. 14 is positive, -2 is negative, 14 is bigger than -2. There are no outliers to the left. Is 79, which is our max, bigger than 54? Yes, so there's definitely at least one outlier to the right. There might be more. Cause this list says that we only see the max here, but when we do the box plot. On the computer, it's gonna show us where all the positions are for the outliers. So if there's more than one. There's more than one, but. This just tells us we can look at it and see if there's an outlier or not. We're gonna use that stuff in the box plot, so how do you do a box plot? Well, to do that, you need to find the 5-number summary. Find the 5-number summary. Next, you find fences. which we just did, we showed how to do it. IQR is Q3 minus Q1, so it's all on one page for you. LF is for lower fence. Is Q1 minus 1.5 times IQR. UF for upper fence. Is Q3 plus 1.5 times IQR. You need these numbers here. Draw a number line. With the 5 numbers. And fences. On it. So that's a new step we have right here. We're gonna do this simultaneously. No, we won't do it simultaneously because it's gonna be harder on your notes to do that. I'll verbally describe the words and then we'll do it together. Okay, now that you got a number line, draw vertical lines. Above. Q1. The median. And Q3. And make a box. It usually looks something like that, or something like that, or it might be evenly balanced where there are lines in the middle. But you're gonna have a box like that. Then we have something called the whiskers. Draw the whiskers. How do we do that? We extend a line. From the box. To the 2 fences. What they do, what it's doing is we make this thing like this on both of them. Box plots ends up looking something like this. Now, generally, the way StatCrunch does it. So the one on the left, this one is like the greatest. Non-outlier. Nope, that's the lowest non-outlier. Lowest non-outlier. So like the fence might be here. Or the value might be on the fence, might be directly on the fence, but it's the first data point inside the fence. It's like if your dog's barking, it's the dog that's closest to the fence. Same with the upper one. When the computer does it, it's gonna do the greatest non-outlier. So the fence is just a little to the right of it. Usually. And finally, for outliers. They put asterisks. to mark outliers. This is a list of the steps, we're gonna do it by hand in a second. Cause like words are like following word instructions, that's not fun. It's not fun doing it when you're cooking, it's much more fun to just fucking have the shit measured out and go. When you're baking. When you're really good at it, you stop looking at the recipe, you just wing it. And hopefully you didn't go see, no, fuck that shit up. My friend's mom was getting old and she meant to put cinnamon in something and she put. Was it curry? It was one of the brown spices that looked very similar in color. It's either curry or cayenne pepper. Cumin, it was cumin. She put cumin in rather than cinnamon. And it was, cinnamon generally is a dessert thing, it was a dessert thing and. Everybody was like, took like one bite, like, what the fuck is this? Everybody stopped eating it, including mom. Except mom's husband. He dutifully ate every bite and said that was good. And I know he was kissing ass. Alright. So following recipes kind of sucks. Let's do this with what we had in our phone. So I'm gonna rewrite down my information here. I had min was 14. I had Q1 was 19. Median was 33. No, median was 22. Q3 was 33. Max was 79. And I had a lower fence. At -2. And my upper fence. When we calculated it was 54. We're gonna use those data values and we're gonna build that box plot. I can just hit fucking omega bright. Super good. Alright, so. My lowest number here. Is -2. And my largest is 79. So what I'm gonna do is I'm gonna build a number line that has numbers close to that. I'm gonna put 0 on the left. And I'm gonna put 80 on the right, because. Using whole numbers, like. Even multiples of like 10, kind of makes it easier to figure out like. Where the other values on the number line go. If you've got graph paper you're measuring out, that's great. What is halfway between 0 and 80? 40. Halfway between 40 and 0 would be 20. And 60. Maybe I'll put little sub increments in here, this is 10. 30. 50. 70, this is gonna help me draw my box plot. I'll do my fences in red. My lower fence is way the fuck over here. And my upper fence is about halfway between 50 and 60. Fourteen's about halfway through 10. That's my min. 19 is right there, that's Q1. 22 is super close to 20 as well, that's That's the median. Q3 is like closer to 30 than 40. Q3 is about there. So I've got 14, 19, 22, 33. And my max. is way over here. Okay, that was draw a number line, I said draw a number, that should say draw a number line. I said that shit out loud and then I didn't write it. Draw a number line. And then what we do is we're gonna take and we're gonna draw vertical lines above Q1 median and Q3. And we're gonna connect them and make a box. We're gonna draw a whisker on the left going to the lowest non-outlier, which is the min. The min is inside the fence, so we're gonna just stop at the min. And from the right side, we're gonna go up to the upper fence. If you have the data value, you know where it is. You can stop there. I imagine it's pretty close to the upper fence. I'm gonna put it right there. So this is called the box plot. Sometimes it's called the box and whisker plot. And sometimes it's just called the whisker plot. You'll see all sorts of names. I believe StatCrunch calls it box plot. We're gonna do it on the computer in a second. Really fucking easy. And then what we're gonna do is for every outlier. We had no outliers, min was the lowest number, so there's no outliers on the left. For the right, there's an outlier at 79. And there may be more outliers in here. You need to look at the data to do it. We can tell from the box plot if this is skewed left or skewed right. Start at the median and draw an arrow to the left, stopping at the lowest value. And draw an arrow from the median going to the right up to the largest value. Which arrow is longer? The right hand arrow is longer. Draw an arrow from median to left. And median to max. Whichever is longer. Indicates skew. Skewedness. This is gonna be a skewed right data set. Even if it doesn't show, like if there's no outliers listed, you can still like get an idea of going from the middle. Like the whisker and the box on the right are bigger than the shit on the left. You can kind of tell which side's bigger. If they look about the same, then they're not skewed. Not skewed enough to like pick a skewness. So like at the previous graphs I had like pictured here. I would call this one skewed right. Cause this side is longer than the left. I would call this one skewed left. But this one is about the same, so man, there's no, like it's not skewed. Looking at the little like pictures I drew earlier. This gives you an idea when you're looking at the box plot, because you're not gonna do any shit when you get a box plot. You'll usually see them, or if you do them yourself, you'll do them on the computer, but like, it tells you stuff when you're looking at it. The middle of the box tells you where the median is. The left of the box is the 25% mark. The right of the box is 75% mark. A small box means there's a lot of data numbers right really close to each other. A wide box means it's more spread out. And then the like how long the whiskers are kind of gives you skewedness. How do I do this in StatCrunch? I know, it's just so tedious. Graphs. Most times you want a graph, you're gonna click graph. There will be a couple things that you consider a graph that are under something else, but that's later in the semester. I'll show you when we get to that. But like your bar plots, your pie charts, your box plots, they're all gonna be under graph. You wanna go see how close we were to our data set, drawing it by hand? Let's go do this in StatCrunch. Does anyone need this a lot? Okay. Box plot. We did age. Make sure you click, I need to write this on the paper, click draw boxes horizontally. I'll write that on page when I go back to it so you can see it, but you wanna click that. Because the vertical ones are harder to read. So my line went all the way down to 0, because that's where I had the lower fence. Notice that the computer doesn't bother showing where the lower fence is. Like here's 20, here's 30, so like 10 is lower than like past this line. This is where the 14 is. Notice if I put my cursor over it, it tells me the lower limit value. The lowest value is 14. They don't use asterisks, they use dots, but the one on the furthest on the right, 79. It does indicate outlier. And notice it will even tell you what row it's in. So, oh, it didn't on there. My outlier, my age 65 was in row 114. If I go down to row 114. Age 65 is right there. So putting my cursor over it like tells me where you can find the data. If there's more than one of that value, it doesn't do it when you do it like this. You can put it over anywhere on the graph. Shows me Q3. Oh, here it's showing me like all the information. There were 7 outliers. It gives me the lower limit, the Q1, the median, the Q3, the upper limit. We got 54. I don't know where they got 52. That might be the lowest age is below the fence. We can check. I'm gonna do data. Arrange. Nope, that's not what I want. One of these allows us to sort it. There it is, so scroll down. Data sort. I'm gonna sort all the columns. By age. And I'm gonna do descending because I wanna see where those outliers are. So I had a 79, a 65, a 63. Looks like there was two 61s. My graph only shows one of the 61s. There was a 58, a 57. Our fence, we said our fence was at 54. 52 was the next number below it. And that's where they're showing as the upper limit is 52. So is that data point that's closest to the fence without going over or outside of it. So that's kind of how you read the box. This is much farther from the center to the right, so it's skewed right. That's how the box plot works. Any questions? No, okay, you're pretty good. You can go. Or if you want to stick around and ask questions, I will stay till 7:30 or until everybody leaves. I will see you guys Thursday. Thursday, we're starting in chapter 5. We will do chapter 4 after the midterm. You're not gonna like chapter 4. But it's after the midterm and I'm not testing you on chapter 4. Okay. Yeah, probably. Bit. Go back to the sentence. No, he had pop-up blocks. You have pop-up blocks. You have the, see, you not get in? Alright. See now you're in. And you shouldn't have to do it again. Alright, we'll see you.
Okay. Yeah, I don't think my back
Did you reload or log out like I told you? Cause I don't see all the. What?
I did.
Oh, it's showing current assignments. Click on assignments. Now you can see the full list. You'll be able to click on them. Click on one. Okay. So up here. It says pop-ups were blocked on this page. I will fix it. It won't pop up again. It won't happen again. So click on the assignments tab to get to the access to the old ones. And now when you click on it. It'll pop up.
Thank you.
Yeah, enable pop-ups. Yeah,
Yeah, you have to enable it. That's what mine was.
you can enable it just specifically for Pearson.
Yeah.
And it won't do it on every other website, so like. Yeah,
Thank you.
next question. I'm here for another half hour if you have questions.
Oh, I'm just.
In general,
Like to the midterm, I know there's really.
go to the math lab center. The tutoring center, they all know statistics there. The guy that came in and gave a little presentation, he's got like, he knows all this shit really well, probably better than me.
Okay,
Cause he's got a full blown degree in.
so is there a one-on-one with you or? There might be.
I can arrange to do one-on-one, generally I try to just do office hours in here, but like, if you have a particular thing and. You can always do ask my instructor on the question in Pearson, they'll send it to me and I'll respond to it. If my response doesn't work, I can meet with you on Zoom over that, and if that doesn't work, I can arrange to meet you on campus somewhere. But like, usually email or Zoom works, cause I have a camera, I can write out to you stuff on the computer.
Thank you.
Uh-huh.
I have a question.
Yeah.
emailed me last night or this morning. I was having trouble with this, I couldn't see if you responded back.
I may not, have, depending on this way, I've been busy, super busy
It was
all
like, probably
day.
like around 2 in the morning.
No, it was like 2, 3 in the morning. They were-
Oh, I definitely, it was like, yeah, that's not last night, that's, everybody else was asleep at that time. Let's see. So if you click on this,
Cause I tried doing view the example, but I still don't understand.
so click, if you. Have this little button here,
Mhm.
we can say open in StatCrunch. Using Apple, so I don't know how to go back to the previous window. What was the question asking? Oh, great. Oh, that's perfect. Ah, fuck. I thought I was gonna do it, fix it, Shit.
I'll fix it right.
there we go.
No problem, sorry, my bad.
Yeah, I don't have an Apple, so I'm not using it. Okay. So the question was. Construct a relative frequency distribution. Using a class having a lower class limit of 90 and a class width of 4. We might be able to do this with. Tables. Frequency. Shit, there we go. We're gonna select the column. bin is telling us. Lower class limit is the first one, we're gonna say that we start at 90. And they tell us it has a class width of 4. So we'll click compute. And it gives us the values over here. That's what we're gonna enter in.
Okay. See, I was not putting the width and the,
Yeah,
it was just
If
giving me
you-
like a
it
little
will
range,
self-select if
and I
you
was like,
don't.
I don't know if I'm doing this right.
so if you
So I
don't
just
do it,
put on
it self-selects, but if they give you a class limit. That tells you what to put in for the lowest one, and then the width is, that's how you get it.
Okay.
That should give you all the values you put in. Notice that if this skips any,
Mhm.
did it skip any? 90, 94, 98, 102, 106, 110, 114, it didn't skip any. Sometimes if the value has 0, it doesn't show up over here, but it's gonna be on here.
Oh, okay.
So make sure you're not just going down the list and filling them in, line up the ones, they should be in the right order,
Okay. Thank you,
okay?
thank you for showing me how to do that, like, I was like, I know I seen a video and I couldn't remember,
Right.
and I kept going back in my notes, and I'm like. I'll just ask. real quick.
That's
And
what
then
I'm
I-
here for.
Thank you.